Welcome everybody. So this is our fourth experiment for civil engineering planning and drafting laboratory. So today we will see how to draw the plan and elevation of a dog-legged staircase. So what is dog-legged staircase? So before going into dog-legged staircase, we will see what is a staircase, what are the components of a staircase, what are the basic dimensions and measurements you need to know before planning or before designing a staircase, and how will we draw the plan and elevation of a dog-legged staircase. These are the things we are going to see today. Okay, you can see these are all staircases which we commonly used in all our houses. First of all, I'm going to show you different types of staircases. Okay, these are the images I have taken from the net just to show the different types of staircases. Here you can see these staircases are like a cantilever. That is, you have a support and on both the sides of the support. See, cantilever means one end is fixed and the other end will be free. So here both the ends, this is one part of the cantilever, this is another part of a cantilever. Cantilever, cantilever. Okay. So this is one type of staircase. See, this is another type of staircase. Here the staircase, here you can see this is called flight. There is one flight, then this is landing, then another flight. From this to this there is another flight. Okay. So here you can see this steps are placed close to this wall. This is another type of staircase. So this is another staircase. You can see this is also close to the wall, and on the right side you can see rails, supports, handrails, etc. Okay, so this is one flight and this is another flight, right? You can see this is one angle. If we take this angle as 0 degree, the next flight is going this manner. Okay, so about 180 degree. It goes like this, then comes like this, goes and comes. Okay. So this is another type of staircase. You have a flight, landing, and then another flight. So another type of architectural, nice, beautiful staircase. Okay. Okay. Now, so there are many more types of staircases. If you Google, you can see lot of staircases of different sizes, different shapes, different beautiful architectural textures made of different materials, etc. Now, let us see what is stairs and a staircase. So, what is the purpose of this stair and staircases? It is used for communication between two floors or two parts at different levels. So we will have different types of buildings, residential buildings, commercial buildings, industrial buildings, multi-story buildings, etc. So for these buildings, when the floors are at different levels, so in order to have a communication between these floors, between a floor and a roof, we will have ramps, escalators, ladders, etc. And another way, another source which we use for communication is stairs and staircases. So what are stairs? Steps, you know steps, right? Every houses we will have steps. So the steps, so these are steps. So steps made in the form of a series of rising footing is termed as stairs. So series of steps we call as stairs when there are more than one step, 3, 4, 5, more than 2 or 3 steps. When there is a series of steps, we call it as stair. So a couple of steps built in series is known as a flight. So when you have many steps, so this is spanning in one direction. So from the bottom to the top, see all these steps are spanning in one direction. So this to this. So this is called, this portion, this is called flight, flight of steps. So your steps or stairs may sometimes change the direction. So when there is two direction, you will have two flights. When you have one direction, you have one flight. So that is what is called flight. Now, stairs can be made into many shapes and designs out of any building material, as I have told you earlier. So, we will move on to the next, that is parts of a stair. Let us see the different parts of a stair. Okay, so this is a simple staircase. So, the basic components are marked here. We will see one by one. First is what is called thread. Okay, the horizontal member which forms the upper surface of a step. See, these are all steps. This is one step, 2, 3, 4, 5, 6, 7 steps and a landing. Totally 8. Right? So, the horizontal member which forms the upper surface of a step. So, this is the upper surface of the step. For this step, this is the upper surface, upper surface. So, this upper surface is called thread. Okay, the upper surface is called thread. Now, we will see what is a riser. You can see here it is mentioned as a riser. Right? So, it is the vertical front portion of a step. So, this portion, see this portion, that is the front portion. You call it as riser. Okay. Now, next is rise. See, there is a difference between riser and a rise. See, this portion is called riser. This portion is called riser. Now, rise is the vertical distance between two upper surfaces of two successive steps. So, this is called rise. That is, the distance, this vertical distance is called rise. So, this vertical portion is called riser. The vertical distance is called rise. So, that is the difference between rise and riser. The portion is called riser. That is the vertical portion. Vertical face is called riser. The vertical distance between the two steps is called rise. Next is balusters. You can see here baluster. See these vertical members. So, these vertical members are called balusters. So, vertical members which support the handrail are known as balusters. So, what is handrail? See, you can see here. So, this is called a handrail. This handrail, that is, which helps us. See, when we walk up or down these steps, we will place our hands on this handrails for support. Okay, we touch this, we catch this handrail and we walk up and down. So, these are called handrails. So, the vertical members supporting this handrail to the steps. Okay, this is handrails. These are steps. These are steps. So, the vertical members joining the handrails and the steps. These are known as balusters. Now, we can see some more components in this step. Okay, this is another type. So, here more components are shown. So, nosing. What is nosing? So, you can see here floor nosing, right? Floor nosing. So, what is nosing? You all know in our face we have a nose. It is the sharpest point of our face, right? That is nose. So, what is nosing? The front edge of a thread is termed as nosing. So, we know what is thread? These things, right? This portion, that is the horizontal portion, is called thread. So, the corner, see in this horizontal portion, this corner portion, the front edge, the edge portion of the thread is known as nosing. So this is known as, so the edge is known as nosing. This is known as thread nosing because this is the edge of a thread. See here it is known as floor nosing. See the end of the floor. This is known as floor nosing. Okay. So this step from one floor to another floor. So this corner, this end, this edge is known as floor nosing. Now line of nosing, line of nosing. So what do you mean by line of nosing? Imaginary line joining the nosings and parallel to the slope of the stairs is termed as line of nosing. You can see this is one flight, right? This is a landing, this is a landing, and this is one flight. So the slope of this flight is the same. This flight has a slope. So the imaginary line of the nosing. So these points are nosings. So the imaginary line joining the nosings and parallel to the slope of stairs is termed as line of nosing. So this is an imaginary line and is parallel to the slope of the stairs. Now what is a flyer? A regular and rectangular step is known as flyer. Okay. So every steps, if it is a rectangular shape and regular, we call it as a flyer. Next is flight. As I have told you earlier, a series of continuous steps between two floors or floor to landing or landing to landing is termed as flight. Okay. So it can be from floor to floor. See, if the landing is between two floors, you will have one flight. From one floor to one floor, you will have one flight if this is floor to floor. If it is from floor to landing, here you can see this is from one floor to landing. Right? If you are taking this as the floor level, this is the second floor level. See, you have 1, 2, this is winders, right? So 1, 2, you have 2 landings. Right? So a series of continuous steps between two floors or floor to landing. Okay, so floor to landing or landing to landing. See, what this is one landing, this is another landing. So this is called flight. This is called flight. This is called flight. This is called flight, and this is called flight. So hope you understood. Next is landing. So this is called landing. Okay. So what is landing? It is the horizontal platform which is provided between two flights to serve as a rest. Only purpose is you can rest it. It also helps in turning of stairs. Okay, when you have a limited space, you will go for turning of stairs. So this landing will help you. Next is soffit or planter. The undersurface of a flight is called soffit. So you cannot see the soffit or planter in this diagram. It is the under portion, under surface. See, this is a flight. So the under surface, the below the flight, you call it as soffit. So now strings or stringers, you can see string, right? So these portions, see, supporting the stairs, the portion supporting the steps are called string or stringers. So these are inclined members. Okay, so these are inclined members. Okay, so the inclined members which support the steps are called strings. The strings may be provided on each side of a step or in the center to support steps as cantilever extending on each side. So here we can see the string on both the sides. Sometimes you will have one string and the steps on both the sides of the strings. So it is nothing but the supporting member, the inclined member which is supporting your steps. Now handrails. Okay, so you can see handrails. It is also known as banister. You can see this is handrail, right? So when you move up and down the stairs, this handrails will help us as a support. It gives us protection. It safeguards us. Okay, that is what is called handrails. So handrails are provided on the top of balusters. So these balusters is the support between the handrail and the steps. So handrails are provided on the top of balusters. It safeguards the persons using the stairs. So whoever using the stairs, these handrails will safeguard us. Handrails may be made of different materials, wood, masonry, RCC or synthetic materials. It can be fixed even to the walls of the staircase. If the staircase are close to the walls, you can fix this handrails to the walls. That is the meaning of that. And toughened glass is also being used as railings these days. Glass for architectural purpose. Okay. Now, see, you can see some more. That is what is headroom. See, headroom. The other things we have seen. What is nosing, the rise, all we have seen. Now, what is headroom? So the vertical distance, see this distance is called headroom, okay, this distance, the vertical distance between the line of nosings. See this line is called line of nosing. The reason is, see this tip, this edge is nosing, the edges are nosing. The line joining the nosing is called the line of nosing. So the vertical distance between the line of nosings and the soffit or landing of a flight. Okay, see this is the landing, right? The flight, this is one flight. So this flight, the landing of this flight is here. So the vertical distance between the line of nosings and the soffit of the landing. So this vertical distance. Or landing of a flight immediately above is known as headroom. So this distance. When you come for this nosing, it is this distance. So the distance varies. So throughout the flight, see from bottom to top along the flight, this headroom distance is varying, right? So headroom, so immediately above, this is known as headroom, and headroom should not be less than 2.2 meters. See this distance, this vertical distance of the headroom should be at least minimum 2.2 meter. Otherwise, if it is less than 2.2 meter, if it is like 1 meter or 1.1 meter, what happens is when you walk, you will hit, your head will hit the landing or hit this floor. Okay, so your minimum distance or minimum vertical distance of the headroom should be at least 2.2 meters. Okay. Now, what is slope of a pitch? Slope or pitch? Slope I have already told you, right? So this is called the slope of the steps. This is also known as pitch line. That is the imaginary line on the nosing. Line of nosing, right? It is also known as pitch line. You can see here headroom not less than 2 meter. Now the slope or pitch, the angle between the line of nosing and floor is known as slope. The angle between the line of nosing, this is line of nosing, and the floor. So this angle, right? So this is your floor. So this angle, the angle between the line of nosing and the floor. So this is known as the slope or pitch. So here you can see the headroom, right? So this is the reason why your headroom, the vertical distance of your headroom should be at least, it should not be less than 2.2 meter, right? Otherwise there should be an opening. Okay, so this distance up to this, the minimum distance should be at least equal to 2.2 meter. Right. After that, if it is going below 2.2 meter, you should provide an opening. Now, another important component is what we call as winders. See, these here you have 3 steps. These are rectangular steps, flyers, okay? These rectangular regular steps. Here you have 3 steps. Here you have 1, 2, 3, 4 steps. See, these are called flyers because they are rectangular and regular. These are called flyers. But these steps are not flyers. They are called winders. They change in angle. They are not rectangle. Right? They are not rectangle but used for changing the direction. So, we call it as winders. Now, the location of stairs. So, where can we locate a stair? See, now you can see based upon your necessity, based upon your need, based upon your comfort, based upon the architecture, the stairs can be located in different locations. But it is better to locate at the center. The reason is stair should be placed at a central place in the building. Central place in the building so as to give shortest access to all rooms. It should be ventilated and airy. So it depends upon our purpose and need. Okay, so it is better if we need to access all the rooms, we should provide these steps at the center. Okay, you can see here, see the steps going up, then going up in the other direction. So the direction is exactly 180 degree, right? See, this is one, you can see this, it's not more, okay. This is one direction and just the opposite direction, right? 180 degree. Right? If you draw the line of action, you will get it as 180 degree. If you join these two parallel lines, these two are parallel. See, parallel steps, right? Parallel steps. Okay, so the angle is 180 degree. This you call as dog-legged staircase. This is called dog-legged staircase. Now, a dog leg is a configuration of stairs between two floors of a building, often a domestic building in which a flight of stairs ascends to a half landing before turning at the right angle and continuing upwards. See, so it turns at right angles. The steps are turned at right angles and before turning you will have a landing. So this portion is called a landing. Okay, you can see there is a landing here. Okay, so before turning you will have a landing and the turning is right angle. Turning to a, before turning at a right angle and continuing upwards, you will have, see, this angle is a right angle. This is right angle. Then again another right angle. So totally it is 180 degree, right? Now, the flights do not have to be equal and frequently are not. See, the number of the flights do not be equal. That means in one flight you may have some 10 steps. In the next flight you may have 8 steps. So, the number of steps in a flight need not be equal. So, the flight need not be equal. The dog-legged staircase is one of the simplest form of stairs in which a flight of stairs goes up to half step before turning 180 degree and continuing upwards. Structurally, the flights of a dog-legged stairs are usually supported by a half landing which spans the adjoining flank walls. Okay, there will be a landing. Before turning, you will have a landing. Now, from the design point of view, the main advantage of a dog-legged stair are to allow an arrangement that occupies a shorter though wider floor area than a straight flight and is more compact. See, that is the reason, that is the advantage of this dog-legged staircase. It is the arrangement that occupies a shorter though wider floor area than a straight flight. It will provide you a wider floor area and it is more compact. Even though the landing consumes total floor space, there is no large single dimension. The upper floor is not directly visible from the bottom of the stairs, thereby providing more privacy. See, that means if you are providing a single flight, what happens is you can easily view, it will affect the privacy of the people in the top floor. So this dog-legged staircase will provide you more privacy. Now, see, you can see the plan and elevation of a dog-legged staircase. So this is your plan and this is your elevation. So you can draw the plan and elevation in two different ways. You can first draw the plan and then you can move on. You can extend this and you can draw the elevation, or you can draw the elevation first, extend it, and you can draw the plan. It is up to you. So now, before going deep into our plan and elevation, we need to see some of the basic ideas about the dimensions. So first is about the width of a stair. So it should not be less than 1 meter. The total width of the stair, that is the horizontal distance of the stair, should not be less than 1 meter. Now the length of a flight. We know when the steps is like this, so this is called a flight. Okay, this length of the flight depends upon the number of steps. So the number of steps in a single flight should not be less than more than 12. So maximum steps allowed in a flight is 12. If it is more than 12, you have to provide a landing and then you have to continue. Now pitch of the stair, that is the angle between the flight and the floor, that is called pitch, and this pitch should be between 25 degree to 40 degree, not more than that. 30 degree fine will be fine. Now width of landing, you will have a landing. See, at the end of the flight you will have a landing. So this landing, it should be 150 mm more than the width of the stair. So here, if the width of the stair should not be less than 1 meter and this landing should be 150 mm more than the width of the stair. Now winders or kite steps. Winders, you all know, when there is a change in direction, we will go for rectangular steps, and when there is a change in direction, we cannot go for perfectly rectangular steps, right? That is called winders, and these winders should be odd shaped. The odd shaped means they are not rectangular shaped. Okay, so odd shaped steps should be avoided, and in case found necessary, these should be provided at the start of a stair. So these winders should be avoided in the middle of the flight. Either you can provide it at the first, it is better to provide at the starting of the floor or at the start of the stair. Now handrails, it should be 750 to 850 mm in height from the top of respective step or landing. Okay, so the height between the step and the height between these steps and the rails should be 750 to 850 mm. Now step proportions, the size of rise and thread in a stair should be kept uniform throughout the whole stairs. You cannot change. See, for one step, you cannot change the thread sizes. It should be uniform throughout. Okay, we will see what should be the size of the rise and thread. Okay, for the rise and thread, for residential building, the thread, that is, see, this is called a thread, right? The horizontal portion is called a thread and the vertical portion is called a rise. So this thread for residential building, it is advised to have 250 mm and the rise can be 160 mm. See, this is the width of the thread. Width of thread, okay? Width of the thread is 250 mm. And the height of that is rise. This is called a rise. Rise should be 160 mm. And for public building, the thread can be taken as 300 mm and the rise can be taken as 150 mm. For industrial buildings, railway stations, etc., the thread not less than 250 mm. It can take up to 300 mm. 250. It should be greater than 250 mm. So 250 to 300 mm and the rise not less than 150 mm. You can take from 150 to 190 mm for railway stations, industrial buildings, etc. So otherwise, you work out the sizes of rise and thread by using any of the following proportions. If you are not using that, you can go for 2 times rise plus going in mm. So totally it can be 550 to 600 mm. 2 times the rise plus going will be equal to 550 to 600 mm. The rise into thread. The area, that is rise into thread, when you multiply, you should get 400 to 410 centimeter square. And with basic proportion of going 300 mm and rise 150 mm and 10 mm to rise for every 20 mm reduction from going. That is, for a going of 280 mm, the rise will be 160 mm. So the above rules, see, even if we have all these rules for the size of threads and rise, etc., and these rules act as a guide, it will help you, but the actual size depends upon the availability of space while planning the stairs in practical field. If you have a wide space, you can go for a wide staircase. If your spacing is limited, you can reduce the size of the reduce to some extent the size of the thread and rise. Okay, now we will move on to our plan and elevation of a dog-legged staircase. So first of all, I will explain you the plan, right? So see, these are the steps. 1, 2, 3, 4, 5, 6, 7, 8. The steps going upwards. Then you have a half space landing. Then in the 180 degree it comes again the upwards, right? So the direction is changing, right? Upwards, upwards. It is 180 degree, 180 degree, right? So now, see, this is the width of the wall, 300 mm. Here also you can see 300 mm, this is the width of the wall. So these are your steps. This you have a landing, it is called half space landing, and this 300 mm, this is your wall. Okay, thus, and this is also the wall. So size of the wall is 300 mm. Now this landing is 1.2 meter, right? Now you have a door, the size of the door is 1.1. You can see that in your elevation, 1.1 cross 2.1 meter. This is in meter. So you have steps, and it will be clear while drawing the elevation. I will advise you to draw the elevation first and then go for plan. You can do it in either way. Okay, now taking this section XX. That is the first going up, right? So taking this section, okay, see, this is the section. You can see this door, right? So you have a door here. This wall size is 300 mm. See, wall size is 300 mm. This is not 300. This wall size is 300 mm. You can see the steps here. See, 1, 2, 3, 4, 5, 6, 7, 8. We have 1, 2, 3, 4, 5, 6, 7, 8. Then we have a landing. That is 9. 10, 11, 12, 13, 14, 15, 16, 17. Okay, 10 since 17 and again 18 we have a landing. Now we will see the bottom half of the elevation. Okay. So now you see this steps is taken from the ground floor. So this is your ground level. Ground level. See, in the ground level, first the floor you have to give compacted earth. You have to compact the earth. So this layer is compacting the earth. So after compacting the earth, you should give 100 mm thick sand filling. So this distance is 100 mm, that is 10 centimeter. So for 10 centimeter you have to give thick sand filling. You have to give a sand, only sand fillings. Now above this sand filling, you have 100 mm thick lime concrete. This is 100 mm thick lime concrete. Above that you have 80 mm thick, that is for 80 centimeter thick lean concrete of 1:4:8. See, 1:4:8 means 1 cement, 4 sand and 8 aggregate. That is the meaning of that. 1 cement, 4 sand and 8 aggregate. And above that you have for a 40 centimeter thick. For 40 centimeter thick, you have a concrete of 1:2:4. That means one cement, C means cement, 1 cement, 2 sand and 4 aggregate or jalli. Call it as jalli, right? Aggregate. So this is 40 mm. This is thick concrete. This is lean concrete, right? You call it as thick concrete and you call it as lean concrete. So this is your ground level, and above this thick concrete you have a floor. So this you call it as floor level, and in the floor level, above the floor, at the floor you have a 40 mm thick damp proof course. This is called DPC, means damp proof course. That is a cement concrete of 1:2:4. This is for the purpose of damp proofing, right? Now, so the distance, this distance is totally it is 600. Totally it is 600, right? Up to this it is 600. Now, this is called floor level. So this is your steps. You can see the steps. So the distance, see your handrail, this is called balusters. These are balusters. This vertical members are balusters and this is handrails. Okay, so this 186 mm, this is the distance of this thread. This we call it as, sorry, rise. This is rise. The distance of the vertical distance of rise is 186 mm. Now, the distance between this nose and the handrails is 750 mm. 750 mm. So this is the distance between this nosing and the handrails. Now, Now, see this distance, that is the handrails, the thickness of the handrails is 120 mm. Handrails, the thickness, see this is wooden railing given as 120 by 40, that is 120 thickness and 40 is the width. This distance is 120 and the width will be 40, that is why it is 120 cross 40. Now, see here you have concrete fillings. Okay, this symbol, this is your concrete fillings. So your concrete, these are the concrete fillings. Now, these are the reinforcement details, reinforcement bars. So these are your main bars. See what you can see here. See, this is your main bar. Okay, this is your main bar. Another main bar is this. See, these are the main bars. You will study these details while studying the design subject. These are the main bars, and the main bars is, this is 12 diameter. That means the main bars are 12 mm diameter. 12 mm diameter main bars with 120 center to center. That is 120 mm center to center distance. You will have these main bars for every 120 centimeter distance. That is why it is 12 mm diameter main bars at 120 mm center to center distance with alternate bars bend up. Okay. So alternate bars will be bending to the other side. Now, see, vertical, sorry, not vertical, perpendicular to these main bars you will have, perpendicular to these main bars you will have distribution bars. See, the distribution bars are 10 mm diameter, distribution bars at 180 mm center to center distance. See, if this is the main bars, this will be the distribution bars. Okay, that will be placed perpendicular to the main bars. So that distribution bars cannot be seen in this diagram. Okay, so it is placed perpendicular. You can show it with the help of dots. So that is 10 mm diameter distribution bars at 180 mm center to center distance. So what else is here? See, these are the hanging frills above the door. Okay, above the door and the dimensions of the hanging frills. So thread is 250 mm and the rise is 186 mm. You can see here 186 mm. And this width of this thread, this width, that is thread will be 250 mm. Everywhere this distance is 250 mm. Okay, now we will move on to the upper half. Okay, the bottom portion I have explained, the plan I have explained. We will move on to this top portion. You can see the top portion of the elevation. Here you can see this 300 mm, right? See, this is the thickness of the wall. See, this thickness is 300 mm wall thickness. Here also the wall thickness is 300 mm. See, up to this height the wall thickness is 300 mm. Because you have a landing here. Okay, up to this. Above this landing for a height of 200 mm. Above this, your wall thickness is 200 mm. The reason is here this is the top of your building and after this you will have a parapet wall. So if you have multi-story building, you will have 300 mm wall thickness throughout. So here it is only 200 mm thickness and here for architectural purpose you have a glazing wall. And the wall thickness is 200 mm. Here also 200 mm thick wall. And this is plaster, right? 12 mm thick cement plaster. That is above the wall, outer of the wall you will have a 12 mm thick cement plaster and this is masonry walls. This symbol means masonry walls. Here on the slab you have 100 mm thick RCC slab, 100 mm thick. Okay. And this is your slab Above the slab you have a bituminous felt, and above that you have a brick border of 100 mm thick. So this is a brick border of 100 mm thick. This is the brick border of 100 mm thick. And this distance is 450 mm. The distance between the wall and outer edge of the slab, this is 450 mm. Now, see, this is your door, and here the distance, this baluster is 12 cross 12 square rods. So all these vertical members are 12 mm by 12 mm cross section square rods. And the railings, the details of the railings are wooden railings 120 cross 40, and in the middle you have flat screwed railing for architectural purpose, right? In order to fix this wooden railings with the balusters. You have 30 cross 6 mild steel flat screwed to railings. This mild steel flats, that is 30 cross 6 mm mild steel flats are screwed to this railings. That is what you can see here in this white color. Okay. So hope I have explained you all the parts, about the section and elevation. So you can complete this and you can submit it in your classroom. Thank you.